Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to understand what is the role of the dose response relationship. So in the microbial risk assessment the dose response relationship is the function that connect the anticipated pattern of exposure to the expected level of the adverse effect. In generic term, the expected proportion of the population that will experience a risk of a particular outcome, that is P, is written as a function of average dose, that is D, administered to that population, and that is written as P is equals to FD. Okay, so in this, it simply means it is a type of a, you can say, a relationship, that is a dose and a response relationship, or it is a relationship of a exposure and response relationship, and which basically describe the magnitude of the response of an organism. Okay, what is the response of an organism that is being described by this relationship? Which type of response means as a function of exposure, that you can call it as a dose to a stimulus. It could be usually any chemical, then after a certain exposure time. So this dose response relationship, it can be described as a response curve also, and this is explained in terms of a response, that is a chemical response, and exposure in the form of a dose. So the stimulus response function or a stimulus response curve, it is defined broadly as a response from any type of the stimulus, and it is not always limited to chemicals, that I have told you na. It is not always refers to a chemical. Let us understand this with the help of a curve. So if I draw a curve, that is a exposure dose relationship or a dose response relationship, so the curve looks like this. So if this is a curve, here it is a response, I am marking it as R, and here it is a dose. Okay, so the curve somewhat look like this. Okay, here there are lots and lots of response are there, here the lots of dose are there, and this is a curve look likes. Okay, so this is a curve, which relationship it is defined as by this, that is P is equals to F into D. So in generic term, when an expected proportion of population that will experience a risk of a particular outcome. Okay, so it is defined, it is written as P, and the further it is equal to F into D, where D is the average dose, written as the average dose that is administered to that population, and the graph look like this. Okay, here is a lots of and lots of responses, there is a dose, and the curve look like this. Somewhat it is like this. Now moving further, the dose response modeling. So the in the biological basis for a dose response model, it derives from a major steps in a disease process, as they result from an interaction between a pathogen, the host, and the matrix. So we all are familiar with this term, that is a pathogen. Pathogen, it is any foreign body that invade a particular organism. Okay, and it is very important for any food manufacturing industry to manufacture a food that is free from these type of pathogen. So here in this dose and response modeling, we will going to understand how it basically occurs. So there are major steps in the disease process, means whenever there is a disease, there is a foodborne disease, or there is any adverse disease, a chronic disease, so there they require a major certain steps. Okay, and these steps or these disease result from the interaction of pathogens the host and the matrix. So the infection and the illness, it can be seen as a resulting from the pathogen successfully passing a multiple barrier in the host. For example, we fall ill, ठीक है, हम बीमार होते हैं, तो वी एज अ होस्ट हम कैसे बीमार हो रहे हैं कि जैसे अगर हमें कोई फीवर है, वायरल फीवर है, तो उसका जो इन्फेक्शन है, उसका जो पैथोजन है, वो उसको वो जगह मिल गई, उसको वो पैसेज मिल गया कि वो हमारी बॉडी में एंटर हो सके। किसकी बॉडी में? होस्ट की बॉडी में एंटर हो सके। एज सून एज इट गेट वे टू एंटर इनटू द होस्ट बॉडी, वहीं से क्या होता है, इलनेस स्टार्ट हो जाती है। ओके, एंड देयर ऐसा नहीं कि हमारी बॉडी में बैरियर्स नहीं है कि उनको स्टॉप करें, बट वो इतना स्ट्रॉन्ग होता है कि वो सारे बैरियर्स को सक्सेसफुली पास करके होस्ट की बॉडी में एंटर करके उसको बीमार डाल देता है। ठीक है, सो इन दिस सिचुएशन, इसीलिए हम लोग कहते हैं कि नाउ डेज पीपल आर बिकमिंग मोर कॉन्शियस अबाउट व्हाट दे आर ईटिंग, and even the food safety officer, even the whole food industries is working on the quality of the food product, means एक ऐसा food quality बनाना that is free from any sort of microbial contamination, या एक ऐसा food बनाना जिसको खाने के बाद after having that particular amount of food your immunity get boost up, क्योंकि अगर immunity बहुत strong होगी, so जो बैरियर्स हैं वो इतने ज़्यादा स्ट्रॉन्ग होंगे दैट नो अदर पैथोजन, नो अदर फॉरेन बॉडी get a chance to enter the body. So it is very important to have a food, to have a high quality food, a food that is rich in immunity. Okay, so that will help a particular human to fight against a different types of pathogen entering the body. Now, coming back to the topic, that these barriers are not at all equally effective in eliminating or interactivating the pathogens, and may have a range of effects depending upon the pathogen and the individual. So, sometimes the barrier cannot have that much capacity to stop the pathogen in entering the body. So, it is very important to see our lifestyle, how you can build your immune system, how can you build a stronger barriers against these kind of pathogen. Now that each individual pathogen has some particular probability to overcome a barrier, right, which is a conditional on the previous steps being completed successfully, the disease process as a whole, and each of the component steps may vary by pathogen and by host. Pathogen and host can be grouped with regard to one or more component, but this should be done consciously and transparently. So, see, once the pathogen gets an entry into the body, so it will anyway invade the body, it will anyway invade the host. So, it is very important to have a very strong barrier so that they can fight against those type of pathogens. Now, if you see this slide, there are some major steps in foodborne infectious disease process. So, how it is, when first the body get exposure to different kinds of host. यहाँ पर आपकी बॉडी को एक्सपोजर मिला है किसके थ्रू? पैथोजन के थ्रू। ठीक है, अगर मैं यहाँ मार्क करूँ कि यहाँ से पैथोजन एंटर हुआ है, आफ्टर द पैथोजन गेट एंट्री इन द बॉडी, इट विल इन्फेक्ट द बॉडी, यहाँ पर वो इन्फेक्शन कॉज करेगा। ठीक है, आफ्टर कॉजिंग इन्फेक्शन द पर्सन मीन्स और द होस्ट गेट इल, होस्ट में इलनेस आ जाएगी, ही विल फॉल इल, ही विल फॉल सिक, then what happened, then illness, how to treat the illness? To have different kinds of medication, okay, to have a proper amount of diet, to fight this infection. Okay, so illness sometimes it is easy to cure, sometimes the illness gets so adverse that it will lead to a death of a person. If a body get a proper amount of medication at the right time, he will get recovery, recovered हो जाएगा. बट अगर इलनेस इतनी ज़्यादा एडवर्स हो चुकी है, पैथोजन ने इतना बॉडी को एडवर्स कर दिया है, सो देयर आर चांसेस of death also. So depending upon the intensity, depending upon the yes, you can only call intensity of the pathogen, it will decide whether it can be cured with a medicine or not. Sometimes you take medicine at your place, you will be fine after 2 to 3 days, but sometimes the infections are so serious that you get admitted in the hospital. Sometimes infections are so severe that no medication helps. Even sometimes your body could not respond to the medication that is being provided, and ultimately death of the person occur. So it is very important from the day that if you find your body not performing a specific functions, अच्छे से function नहीं कर रही, आपको health में कुछ problem आ रही है, so it is very important to have an immediate you know have immediate contact with the doctor, so that at the right time, at the correct time, you get medication and you can get recovery. Now, a dose response model, what it basically describe? So it basically describe, the probability of the specified response, okay, from the exposure to a specified pathogen in a specified population as a function of a dose. So this function is based on the empirical data that we have discussed in slide 1, and will usually be given in the form of a mathematical relationship. So the use of mathematical model is needed because of the following points. But firstly, let us again understand what is a dose response model. That is, what is DR model. So DR model basically it describes the probability. Which type of probability? Of a specific response. When this response get exposure from a response from the exposure to a specified pathogen, and in the specified population how it is doing its function, means as a function of the dose and what it gives. So it is not basically it gives, it is based on a mathematical formula, or you can say relationship, or you can say it based on the empirical data that will collectively form a mathematical relationship. So the mathematical model is needed because of the following. So the first one is contamination of food and water that usually occur with low number of exponential circumstances. So whenever there is a contamination of food, whenever there is a contamination of water, and that is one of the reason the use of the mathematical model is needed, because of the contamination. And this contamination can be occur from different kinds of pathogens, that is bacteria, viruses, fungi. Even sometimes they occur through a physical contamination, sometimes it occurs through a chemical contaminations. Okay, so now second point is pathogen in food and water are usually not randomly dispersed but in appear in distinct clumps or cluster, which must be taken into account when estimating health risk. So whenever a person is estimating the health risk, whenever there is a mathematical models, so first of all see for the pathogens that is there in food and water. Okay, sometimes pathogens they appears in distinct type of cluster or clump, and it is very much important to take into account when you are estimating any health risk. Okay, so it is very important to monitor pathogens that are present in food and water. Now, the third point says experimental group sizes are limited, that is, the model are needed. Whenever there is uh, experimental group sizes, they are in limited number, so then also the mathematical model is needed. Even in a very well controlled experiment, when the experiment is controlled, is being conducted in a very controlled manner, so to distinguish a random variation from a true biological effect, then also this mathematical model is needed. Now moving to the next, that is, the first is the exposure. If we talk about these major food steps, the first one is the exposure. So in general, the biological plausible dose response model for any microbial pathogen, they should consider a very the particulate nature of an organism, and it should be based on the concept of infection from one or more survivors from the initial dose. Like, before proceeding further, it is necessary to have a very careful consideration of concept of dose. So the concentration of pathogen in the inoculum is usually, it is analyzed by some microbiological, biochemical, chemical or physical method. Okay, so ideally, if we see this, such method would have 100% of sensitivity and specificity for a great for the target organism. But if you see it, it is very rare in case. So to have this, the it may be necessary to correct the measured concentration for the sensitivity and even for the specificity of the measurement method, to provide a very realistic estimate of the number of viable infectious agent. So the result may be greater or small than the measured concentration. You have to note that in general, the measurement method that is used to characterize the inoculum in a data set, it is used for a dose response modeling, will be differ from the method that is used to characterize the exposure in the risk assessment model. Now comes the infection. Infections means that every individual, every organism, when it is in the ingested dose, it assumed to have a distinct probability of surviving all the barriers to reach a target site of colonization of microorganism. So there is a relationship between the actual number of surviving organism, and there is a relationship between the actual number and the probability of colonization of the host. It is a key concept in the derivation of dose response model. So in infection, it is commonly defined as a situation in which pathogen, after ingestion and surviving all barriers, actively grow and its target site. So sometimes in exams also this question arises that what actually is infection? इन्फेक्शन की जो करेक्ट डेफिनेशन है, व्हाट इज़ दैट? सो इन्फेक्शन को मैं ऐसे बोलूँ कि ऐसी सिचुएशन होती है जहाँ पर जो पैथोजेंस होते हैं, जो हार्मफुल पैथोजेंस होते हैं, वो आपकी होस्ट में एंटर हो जाते हैं और सरवाइव करते हैं जितनी भी बैरियर्स हैं, मतलब जितनी भी बैरियर्स हैं उनको हटा करके, उनको पार करके वो होस्ट की बॉडी में, या यू कह सकते हो टारगेट साइट पे पहुंच जाते हैं। और आफ्टर रीचिंग द टारगेट साइट, दे स्टार्ट growing themselves at a very greater level. So, in this way, infections occur in the organism. And there is a tendency of the microorganism to multiply very fast. Means they multiply very fast as soon as they enters the target site. Infection may be measured by different method. Means there are different method to measure the infection, like fecal excretion or immunological response. So in this way you can measure different types of infection that is there in the target site. Apparent infection rate may differ from the actual infection rates, that is totally depend upon the sensitivity and specificity of the diagnostic assay. So, infection is usually measured as a counter response. What is a counter response? So, the counter response, it is a presence or absence of infection by sub criteria criterion. So, the use of the continuous response variables, for example, antibody titer, it may be useful for further development of dose response model. So, in this way, infection enters the body, infection enters the target site, and it causes a person to fall ill. So it is very important to treat infection as soon as your body find yes there is an infection, because after some point of time it becomes very adverse. As soon as it becomes very adverse, so it will harm the body, and nobody wants our body to get harmed by such type of infections. As already told you that infections sometimes they are easy to be cured, sometimes as soon as they find more you can say friendly environment, so they grow at a very larger number, and in that case it infects the body very uh, adversely, and sometimes they target the individual to a such an extent that a death of a person can also occur. So it is very important to have the infection to sorry to treat the infections at a very right time so that a person can survive. And it is again very important to have a medicine, to have the dose on a correct point of time. Now comes the illness. Illness can basically be considered as a process of cumulative damage to the host. Already told you. As soon as the infection enters the body, okay, see infections how it infection get enter कि भाई उसने जितने भी barriers थे उससे लड़ते 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 हमारी बॉडी में एंटर कर दिया. जैसे ही बॉडी में एंटर करेंगे तो ऑब्वियसली व्हाट विल हैपन, इट विल डैमेज द होस्ट, इट विल डैमेज द होस्ट इन मेनी वेज. भाई इन्फेक्शन क्या करता है, जो होस्ट होता है उसको डैमेज कर देता है, होस्ट की बॉडी को पूरी तरीके से डैमेज कर देता है, सो दैट देर इज नो चांस of a person to be escaped from that pathogen unless and until they get a medicine on the right time. So it leads to the cumulative damage to the host, and it leads to the adverse reaction we all know. So there are usually many different and stimulus sign of the symptoms of illness in any individual, and the symptoms vary amongst the pathogens. Mean different types of pathogen gives different types of effect. For example, if a bacteria enters, different types of even the bacteria जैसे ही वो बॉडी में एंटर करते हैं तो उनका सबका सिम्टम्स अलग होता है, सेम सिम्टम्स नहीं होता है. डिपेंडिंग अपॉन द टाइप ऑफ पैथोजन, डिपेंडिंग अपॉन हाउ दे एंटर्स द बॉडी, on that basis the illness or symptoms varies. infected with same pathogen. Illness is therefore a process that is the best measure on multidimensional quantitative continuous scale, that is number of stool passed per day, body temperature, laboratory measurement, etc. For example, nowadays dengue is one of the pathogen or one of the viral fever that is caused by a mosquito. So every individual who has dengue responds differently, क्योंकि हर एक की बॉडी का मशीनरी डिफरेंट है, हर एक की बॉडी का इवन हाउ इट गेट एडवर्स, किस तरीके की इम्यूनिटी है, वो सब डिफरेंट है. तो डिपेंडिंग कि हमारी बॉडी की क्या इम्यूनिटी है, किस तरीके से वो एंटर किया है, उस पर डिपेंड करता है. तो इसको कैसे हम समझ सकते हैं? थ्रू बॉडी टेम्परेचर, थ्रू हाउ मेनी, थ्रू डिफरेंट टाइप्स ऑफ लेबोरेटरी टेस्ट, बिकॉज नाउ डेज laboratory tests are being conducted for every individual who falls ill, and you get a correct thing how a person is got ill. Now comes the sequel and mortality. Sequel and mortality, it in a small fraction of ill person chronic infection or a sequel may occur. Some pathogens such as Salmonella, Entericia, serotype or typhi are invasive and may cause bacteria, and bacteremia and generalized infection. So the other pathogen, they produce toxins that may result not only in enteric diseases but also have a severe damage in susceptible organs. For example, hemolytic uremic syndrome. They are caused by the damage of kidneys from the Shiga like toxins from the E. coli strain. So again, this is the sequel and mortality. Now there are different modeling concept. So there are several key concepts that are required for the formulation of biological plausible dose response model. So one few are here. So the first model is the threshold versus non-threshold mechanism. Then comes the independent versus a synergetic action, and the last one is the particulate nature of the inoculum. So these are some of the important modeling concept, or you can say a dose response model, and these three are important. So that brings to the end of the lecture. So as far as this lecture is concerned, this dose response modeling is very important. You can also know what are the major steps in the foodborne infectious disease process. Every steps I have discussed, so this is again very important. So that is all about the lecture. Thank you. And if you face any query or any problem is there regarding the lecture, so you can leave your queries in the comment section below. In the next lecture, I'll be answering the queries. You can follow ITLS Academy on different platform, that is Facebook, Twitter, YouTube, WhatsApp, LinkedIn, Instagram. Subscribe ITLS Academy. You can visit our website, that is www.itlsacademy.com. This is our helpline number, that is 7080833450, and this is also our WhatsApp number also. So if you find any queries, so you can simply drop your queries on the WhatsApp as well. So we will help you in overcoming that queries. Thank you for watching. At last, please do like, share and subscribe ITLS Academy. Thank you.